So the problem is x is inside of a square root. So unless we can get rid of that square root, we can't solve. I'm dying. We can't solve for x. So here are the steps. Pretty easy steps. You need to go get a note. Step 1 is to isolate the radical. This is the radical right here, the square root of 2x minus 3. So if there's anything in front of it, if there's anything behind it, you got to move it over to the other side. So this 3, how do we move it to the other side? Subtract.
I thought you did put in a little parentheses square root. Sorry, that sounded silly.
Yeah. Subtract 3 on both sides.
I don't know what I was thinking. I'll just stop laughing. That's why I got in that.
And we have the square root of 2x minus 3 is equal to 5. That's all we had to do to isolate the radical. Now sometimes not quite as easy. Sometimes there's a few more steps involved with isolating the radical, but all we have on the left side is just that square root. So the radical's isolated. Step 1, done. Step 2, I don't know if this is the best way to phrase it or not. Step 2 is to raise both sides of the equation to the appropriate power. You can't just raise it to any power you want. You have to raise it to a certain power that's going to cancel the radical. So if it's a square root that you're trying to cancel, what power are you going to use? A power of 2. But what if this were a cube root? Then you'd use a power of 3, right? That's what I mean by the appropriate power. So in this case, we're going to square both sides. Also very easy to do. If you square something that has a square root, those are opposites of each other, just like adding and subtracting. So square and a square root, they cancel each other out, and you've got 2x minus 3 is equal to 25. So that's step 2. Step 3 now is to solve for x. X is no longer inside of a square root, so you can solve for it. Add 3. Divide by 2. And you get x equals 14. So it's easy enough to solve for, but step 4, you guys. Step 4 is critical. Step 4 is to check your answer, because more often than you would think, with these types of equations, you actually get an answer that's not really an answer because it doesn't work when you plug it back in. We'll see a few of those here in a minute. So with these radical equations or these square root equations, you always need to check your answer. Plug it back in for x right there. So this hopefully you can all do in your head. It's not too hard to do. 2 times 14, 28 minus 3, square root of 25. Square root of 25 is 5, and then 5 plus 3 is 8. So did it work? So x equals 14. There's one clarification I need to make. You might not remember, but it was, I don't know, 3 or 4 weeks ago, we talked about something called the principal square root as opposed to the real roots. You remember that discussion? Doesn't sound like it. What are the real square roots of 25?
Oh, I remember this.
5 and?
-5.
-5. If you're solving a square root equation, this root is the principal root only. It's not talking about the real roots, it's just the principal. That's the positive root. That's why when I ask the square root of 25, it's just 5. That's the principal square. You guys follow? Okay, so 266. You guys on that page?
Right at the top of page 266, there's A practice 1 and 2. You see those? Write down problem 1 on page 266, right at the very top. 3 squared roots of x plus 3 rather than me showing you a board, we're going to talk our way through this one, and then I'll have you do number 2 on your own. Step 1 is to isolate the radical. There's a 3 in front of it, and there's also a 3 behind it. So what do you get rid of first? The adding 3 one. You get rid of that one first. So you subtract 3 on both sides. That's your first step. Subtract 3.
Yeah, and you're right, we do divide, and I see a lot of students goof up on this. So here's what you got to think about, you guys. I see a lot of students want to do this. Subtract 3. I understand why they say that. They say, well, the 3 is positive, so you got to minus it. But what is the 3 doing to the radical?
It's multiplying the root x plus 3.
It's multiplying the root. So what's the opposite of multiply? Okay, so divide by 3 on both sides.
And you get 4. I know it is. Just like going on vacation.
Whatever. Don't care what you think.
Here's a question. What if you got to take a whole week off of school, didn't have to go, and you went to somewhere, but you had to do math? Would that still be a vacation?
No.
Yes.
Because you're not going to school. I mean, you're not.
If it were a vacation,
You were still doing schoolwork on vacation.
That takes away the whole vacation.
Takes away the whole vacation's ruined.
if you went on a cruise and then you had to do math, that's a vacation.
Vacation is a leave for the normal day.
If you call it okay, if you went somewhere to do a service project, third world country, would that be a vacation?
Ooh.
Yeah.
Ooh.
I don't know, vacation. Think of it like that, because that's basically what I did, so. Literally, no technology, nothing. Basically living. Dylan, don't. Don't even don't!
I don't know.
Can you be quiet?
We better not talk about it.
Yeah,
No technology.
It didn't work, so what is that?
Did we even get an answer to this yet?
Yeah, 16.
Well, did you guys check it?
Yeah.
Maybe.
Remember, you always have to check these. The 2 right here. Because if it's a square root, the only way to get rid of a square root is to square it. You got to square both sides. So, let's check it. Square root of 16. Come on, y'all. Square root of 16. 4 times 3. 12 plus 3 is 15. Okay, I want you to try that second one on your own. Go.
Come on. Question 2 at the top of page 266. Try it on your own.
I think we had a guy come up last time. We need a girl.
No, I know what I'm doing, so someone else can.
All right. Brave volunteer. Nice. Just push the button down, and then it erases. Cool, huh? Nice. So far, so good. Hold on. We gotta do this like the Romans did. Thumbs up or thumbs down. If it's thumbs down, she's going to the stadium with a lion. Is it 23? Is that what we're getting? Nice. You get to live another day. Oh, no, wait a minute. Whoa, wait a minute. Did we check this, though? That's okay, that's okay. If you plug in a 23, you guys, let's just do this in your head. 23 times 2. 46 plus 3. Square root of 49. 7 minus 7. 0. Dang, math is easy. Okay, this one's not out of the book, but let's try it. Here's one. Okay, go.
I think you need to sync the magnet.
Let's check it. What'd you guys do first? Subtract 8 from both sides, you get 2 times square root of x minus 3 equals negative 2. Then divide by 2. And you get square root of x minus 3 is equal to negative 1. Then you square both sides, square, and a square root undo each other, so x minus 3. Here's where I'm a bit concerned. Negative 1 squared
Negative 1 times negative 1, and negative 10 is negative 2 positive.
is negative 1 times negative 1, which is positive 1. And if you add 3 over, you get x equals 4. Problem is, though, if you go back to the original, if you plug in a 4 right here, 4 minus 3 is 1. Square root of 1 is 1. 1 times 2 is 2. 2 plus 8 is 10, not 6. So that was no good. Now here's, I need you guys to really try to understand this next part. You didn't actually have to go to the very end of the problem to figure out this problem was no good. You could have stopped right here. You could have stopped right there and said, hey, this is not going to work. Why? That's what I was just going to ask. Why?
Because negative 1 you can't square it.
You guys remember what I said about 15 minutes ago regarding this being the principal square root? You guys need to listen to this, okay? I need your eyeballs up here. The principal square root is just a positive, okay? So whatever x is, we're taking the principal square root of this expression. That's never going to result in negative 1 because the principal square root is always positive. You guys understand what I'm saying? It's impossible for a square root to equal negative 1 if we're talking about a principal square root. So if you really understand what a principal square root is, you can recognize from right here that there's no solution. Okay? If that's not making sense, you're going to have to go all the way to the end and check your answer and make sure it doesn't work. But if you really understand the principal square root, that's an impossible situation. The square root of x minus 3 can never equal negative 1. Okay? Because this is the principal square root. And the principal square root will always give you a positive number, not a negative number. Alright. Let's do some other roots. Well, that's a fifth root.
Oh boy.
Here we go. God, things get so much more the same. These are exactly the same steps. You isolate the radical. You raise both sides to the appropriate power. If this is a fifth root, what power should we raise it to? Fifth power. Okay? A fifth power gets rid of a fifth root.
So these are absolutely no different in any way other than we use a different power on both sides. So add 1. And then, what about that 3 in front? Divide by 3 or subtract 3? What are we doing? Divide by 3 because the 3 is multiplying. So you get the fifth root of x minus 2 is equal to 2. Now you raise it to the fifth power.
2.
Yep. A fifth root raised to a power of 5. Those are opposites of each other. 2 to the 5th power is 32. You can check it on a calculator if you need to. Add 2 to both sides. And so it's absolutely no different than the other ones. You just use a different power.
We are right on that one. I don't think we need any more examples on that. Okay.
New topic. Oh, yeah, we need to check. All right, let's check this one. Plug in at 34. Here we go. 34 minus 2. Here's a tough one. 5th root of 32 is 2, because 2 to the 5th power was 32. So anyway, the 5th root of 32 is 2. 2 times 3? 6 minus 1. That one checks out. So, this one gets a little more challenging. And by more challenging, I mean more fun.
Oh, excellent. Sorry.
There's not only an x inside the root,
There's an x outside of the root. You still follow the same steps. You isolate the radical.
you isolate the radical, and then you square both sides. Whoa, wrong direction.
When you square both sides, you square all terms on the right side.
Ooh, I'm glad you asked. Perfect question. Do we all know what to do first? What's the first step? Isolate by adding 5. Now this surprised me. How many students were a little unclear about what to do? You see what I'm circling right here? These are not like terms. You can't add x and 5 and make 5x. I assumed we all knew that, but there's a lot of confusion. If it was 5 times x, that's 5x. But what's 5 plus x? Just x plus 5, or 5 plus... You can't add them together. Yeah, you have the square root of x plus 7 is equal to x plus 5. Now, there's a pretty good question that was asked, and you all need to listen to this exactly as I say. You can square 1 time on the right side and 1 time on the left side. That's it. What I mean by that is quite often students will say, well, let's just do this. Yeah, that doesn't work. You can square 1 time on the left side, and you can square 1 time on the right side. Okay? Yep. If you want to square multiple terms, it has to be done.
Yeah.
Exactly.
If you want to square multiple terms, it's got to be in parentheses, like that. Okay?
And just so we're clear, I've said this before, and I'm going to say it probably 100 more times, because students always forget. X plus 5 squared does not equal x squared plus 25. It doesn't. Okay? X plus 5 squared means x plus 5 multiplied by another x plus 5. That's what it means to square something. Okay? You have to use the distributive property, and you end up with an extra term in there. That's one of those mistakes students love to make. You cannot just distribute the exponent and square both terms individually. Doesn't work. And that shouldn't be a new thing. You ought to have heard that before plenty of times. If not from me, then from other teachers. So x plus 5 times x plus 5, that's x squared plus, keep going now, plus, did I completely lose you on how to multiply these two together? 10x plus 25, there we go. That's just the distributive property. Ooh, we haven't done one of these in a while. I'm so glad we get to do this. A quadratic equation.
Quadratic formula.
Now we could use the quadratic formula. Hopefully not, because that sucks.
I actually don't mind it.
I don't mind it either. It's actually not too bad. It's not like it stole my lunch money or anything. I've got no problems with the quadratic formula. Yet. It would be so much better this factor, though. In any case, if we're going to use the quadratic formula or factor, it doesn't matter. We're going to have to get one side equal to 0. Right? Isn't that what you recall? With your perfect memories? You're thinking, oh, if we're going to factor this, one side has to equal 0. Bam! That's what y'all remember. So subtract x and subtract 7 on both sides. You can't solve by factoring if it doesn't equal 0. You can't use the quadratic formula if it doesn't equal 0. So make sure one side equals 0. And I'm going to stop here. You guys really ought to be able to continue it on from here. So I'm going to give you a chance to prove me right, because I'm never wrong. Try to finish it from here. Did you factor in x plus 3 and x plus 6? Yeah. So your potential solutions were x equals negative 3 and x equals negative 6, right? But if you were to check negative 6, it doesn't end up working. Negative 6 didn't work. Negative 3 does. So the answer is negative 3. There's a word for this that you're going to see on your homework and on the test. If a solution doesn't work, it's called extraneous. Extraneous. Okay, so in your book, I think it's on page 269 or 267, somewhere on there. Try the problem 4, got it, out of your book. Problem 4, got it. It's not question 4 on 266. It's where in red where it says problem 4. It's on page 268. So go to page 268 to the problem 4. Got it. And give it a try. So, check it out up here. Subtract 3 on both sides, right? Then you square both sides. You end up with this. 5x minus 1 equals x squared minus 6x plus 9. Then you get all the terms on one side, get it equal to 0, and you get x squared minus 11x plus 10. That factors into x minus 10 multiplied by x minus 1. So your two solutions are x equals 10 and x equals 1. If you check them, 10 works. If you plug it back into the original problem, 10 works, 1 does not. Still with me? Here's a different type of problem.
You get the factors of terms that add to 11.
So negative 10 and negative 1 add to negative 11.
The 11 with 2 factors.
Was there another question? Graph? Did you graph this? Well, you have to graph. If you're going to solve this by graphing, you have to use the original. After you square both sides, you can't use any of those equations after you square both sides. Let's do this type of equation. When you have roots on both sides, so now we have not just multiple variables, but you have multiple radicals. One type's very easy, one type not so much. Here's one type. This is a very, very, very easy one. This is even easier than what we've been doing. So you have the square root of 4x minus 1 equals the square root of 3x plus 7. Yeah, they're both square roots. They both have the same index. If you want to solve for x, it can't be inside of a square root. So what if we just squared both sides? Do you think that would work? If you just square both sides, it gets rid of both square roots. And all you're left solving is a very, very easy equation. You have 4x minus 1 equals 3x plus 7. Subtract 3x, add 1. So you get x equals 8. If you were to check it, 4 times 8 is 32, minus 1 is 31. So this side gives you the square root of 31. Over here, 3 times 8 is 24, plus 7 is 31. So over here you get the square root of 31. Both sides are the same. So x equals 8. Those are the easy ones. If you have just one root on one side and just a root on the other side, nothing else, no big deal. This one, not so much. Okay, we are running a little short on time, so right quick. We still have two roots, one on one side, one on the other side, but we have a little bit more. The right side, you have the square root of 2v minus 5, and then a plus 1 outside of the root. Still solve it, you just have a few more steps than the last problem. How many steps did the last problem have that we just did? Like three steps maybe? This one has a few more. What gets rid of a square root? Squaring. So remember what I said though, you can only use a square root. You can only square once on the left side and once on the right side. So we can square here, but on the right side you gotta use parentheses. Do you see where this is going? Left side works out okay. That just cancels right there. So you have 2v minus 2, but check this out. On the right side, you need to write this twice in parentheses. Square root of 2v minus 5 plus 1, and then another square root of 2v minus 5 plus 1. And guess what we get to do? Distribute, just like we did on the last test. So this problem may be more challenging, but it isn't anything that you haven't done before. Okay? You had a problem like this on the last test that you had to multiply together, and most of you passed it. All you got to do is distribute. So multiply here and here. This isn't as bad as you think. Don't these match exactly? So what happens if you multiply a square root of 3 with a square root of 3? What do you get? You just get 3, right? What about the square root of 5 times the square root of 5? What about the square root of 12 times the square root of 12? My point is, if you multiply two roots that match exactly, what does that end up with? Whatever you had on the inside of it. So if you're multiplying the square root of 2v minus 5 multiplied by another square root of 2v minus 5, all you get is 2v minus 5. If you multiply a square root with another square root that matches it exactly, essentially the square root disappears and you're just left with what's on the inside. Now, square root of 2v minus 5 times 1 is the square root of 2v minus 5. None of this stuff is new. We've done this before. What about 1 times the square root of 2v minus 5? Another square root of 2v minus 5. And then 1 times 1 is 1. So combine some like terms here on the right side. 2v doesn't combine with anything on the right side, just stays 2v. But the negative 5 and the positive 1, that makes negative 4. And what about these?
2 minus.
We're adding radicals now. Okay, you can only add radicals if they match exactly. Do these match exactly?
Yeah.
So how many of them do you have? So you have plus 2 square roots of 2b minus 5. Again, we've added radicals before. None of this is new. Left side, all you had is 2b minus 2. It might be hard to spot what we've done so far, but it's pretty dang important. We started with 2 square roots, didn't we? How many do we have now? Just 1. We know how to solve an equation with 1 square root. You isolate it and square both sides. So, subtract 2v and add 4. So you're going to get 2 equals 2 times the square root of 2v minus 5. Should we square both sides yet? Divide the 2. You get 1 is equal to the square root of 2b minus 5. And then you can't. Since the square root's by itself, you can square both sides. Right side you get 2v minus 5. Left side, 1 squared is just 1. You add 5 over. And then divide by 2. 1 plus 5 is 6. 6 divided by 2 is 3. And don't forget to check. Right back here at the beginning. If v is 3, 2 times 3 is 6. 6 minus 2 is 4. Square root of 4 is 2 over here. 2 times 3 is 6. 6 minus 5 is 1. Square root of 1 is 1. 1 plus 1 is 2. So, looks like it works. V equals 3.